This video will show you how to calculate the pH of a weak acid given a known concentration of weak acid and then the pKa of the acid. Okay, so please refer to the theory video that takes us through these calculations. In my spreadsheet, I set up with total concentration of the weak acid. It's in molar, and that's input into cell B6. And that is a known. You would have to be given that information. B7 is the pKa of the weak acid. Again, it is known. We use logarithmic scales for talking about or describing acid or base strength because it is a convenient way to tabulate them. However, when we do calculations, we almost always need the Ka, and so cell B8 is the antilog of, or the negative antilog of cell B7. And there it is, 10 raised to the negative B7. Okay, so we are interested in determining the pH of a 0.1 molar solution of a weak acid with a pK of 4.75. And as we discussed in the theory, the H plus, which I have set as X, is equal to the square root of Ka times total acid. And so I click on cell D7, and you can see I have the square root, SQRT, times B, and looks like I have an error here. So let's fix it. Drag that up here. That's a cool Excel trick. Drag that up there, and we're done. And so that value is 1.3 times 10 to the minus 3, and that is equal to the H plus concentration. Now we have made an assumption here. We've made an assumption that the H plus concentration is small compared to the total acid concentration. So then if you take, so if this term drops out, you get KATA equals H plus squared, or H plus is the square root of Ka times total acid. All right, so the answer comes out to be 2.875. If you take a 0.1 molar solution of a moderate weak acid, the pH is somewhere between 2 and 4. And we can change this. Make 4.75. Let's make it a weaker weak acid. Change that to 6. pH goes up. Let's make it 3. The pH goes down. Let's go back to 4.75. Advantage of spreadsheets is they can let you what if. They can let you play with the data fairly quickly once you get it all set up. Okay, also in the theory section, talked about the fact that if the proton concentration is close to the total acid concentration, our approximation that we used in cell D7 is no longer valid. And one approach is to do iteration to correct for this error. All right, so the first thing I did in cell D18 is exactly the same thing I did above, except I subtracted off this value in cell D19. So let's set D19 to 0. And you'll notice that these two are exactly the same, which setting it to 0 is the same thing as ignoring it. So now I have an estimate for the H plus concentration. Cell D19 is the H plus concentration. So this is a circular reference. So I take equal sign and I make cell D19 equal to cell D18. Now cell D18 references cell D19. And you could say I have a circular reference. And if you do that, Excel will get angry unless you go to Excel preferences and go to calculation and tell it to use iterative calculation. You tell it how many iterations maximum iterations you can use. 100 is a good number. And you could talk about the maximum change. And I set this to 0.001. These values keep it from getting in an infinite loop and spinning away forever and crashing the program. Okay, so now what I've done is iteratively solved for the H plus concentration. So this is a little bit of a numeric trick. And it takes a little bit getting used to, but once you sort of understand what's going on, it's pretty helpful for conditions where the H plus concentration is very close to the total acid concentration. Alternatively, use the quadratic equation, and that will also work. So look at the difference in these two, 4.75, 0.1 molar, my simple approximation, 2.875, 0.01 molar, 4.75, my complete calculation, 2.878. Boy, pH only changed by 0.003. And so in most cases, we can get away with our simple approximation. So this is how you can calculate the pH of a weak acid system using our basic Gen Chem approximations and a more sophisticated approximation using numerical iteration. In practice, we almost always measure the pH in environmental systems, and so I will refer you to the next video where pH is a measured value and therefore known to, for a more extensive conversation of acid-base speciation.